Okay, this is video of notes for 7 inverse linear functions. So an inverse relation is the set of ordered pairs you can get by exchanging the x and y values. So basically switching the x and y values around. For example 1, 3, negative 7. That's your x, that's your y. All you do is do the inverse by switching the x and y around. So negative 7, 3. That's it. So if you have the ordered pairs 4, negative 5, 7, negative 11, or negative 19, negative 5, 17, you just switch each x and y around to make the inverse. So that'd be negative 10, 4 from 4, negative 10. 7, negative 19 would be negative 19, 7. And negative 5, 17 becomes 17, negative 5. Same thing if you have it in a box like this. Negative 4, 13 becomes 13, negative 4. Negative 1, 11 becomes 11, negative 1. 0, 9 becomes 9, 0. And 5, negative 6 becomes negative 6, 5. That's called inverse relations. So from there, if I have a function, f of x equals 4x minus 8, that's the original function. The first thing I do is replace the f of x with y. So replace this with y, because that's what f of x is y. And now you exchange the x and y coordinates around. So that becomes x, that becomes y. From there, you solve the equation for y. So y is on the right side, so we'd add 8 and get x plus 8 on the left side equals 4y on the right side, and then divide every term by 4, which makes it 1/4 x, because that's a 1 right there, 1/4 x plus 2, 8 divided by 4 is 2, equals y, and you switch it around. Y equals 1/4 x plus 2 in exponential form, or not exponential, slope-intercept form. And then you write this symbol. This means f inverse. So you replace the y with f inverse, because that's what the inverse function is 1/4 x plus 2. Now, if we were to put those two equations in our y equals 4x minus 8 and 1/4 x plus 2, we'll see what happens. So if we take and put those two functions in our graphing calculator, let me see if I can get this whole picture in, like this. Y equals here, clear, clear, and clear this out. And y equals stat plot, turn the stat plot off, so we don't need a plot, and turn it off like that. Second quit to get out of there. Y equals, we put in 4x plus 8, 4x plus 8. And then our inverse function is 1/4 x plus 2. So here we're going to do 1/4. Remember 1/4, you put in parentheses, 1 divided by sine 4 parentheses x plus 2. And if you do a zoom square, you'll see that the two lines look like this. Okay? Now, let me take a look at that and see if that's correct. 1/4 x plus 2. Let me see if I got, oh, I put plus 8. It should be minus 8. My fault. Minus 8. I wonder why it was wrong. Now if I had zoom 5, now I have it right. There they are. So those are the two lines, and what they do is they're reflective across the y equals x axis. So if I put the y equals x axis in right here, my third graph, y equals x, you'll see that the two lines reflect over. That flips over that axis right there. And that's exactly what the picture should look like using your graphing calculator. So from there, let's try another one. Example 5. See if we can get this one right. 3y minus 12x equals negative 72. You can see that's not in any standard form or slope-intercept form. But this thing, what you do is change the x and y's around first. So you switch, the y becomes x, the x becomes y. That's the first thing you do, is change the x and y. Then you solve for y. So how do you solve for y? You get rid of the farthest thing from, and you do the inverse operation from y. So you're going to move the 3x over to the right by subtracting 3x. Bring down negative 12y equals negative 3x minus 72. Then divide every term by negative 12, and you get y equals 1/4 x plus 6. Replace the y with f inverse x. That's just a change in the way you write it. So f inverse x is 1/4 x plus 6. Now I can put this in my graphing calculator, but in order to put this in the graphing calculator, you first would have to solve it for y. So it's a little harder to check that on the graphing calculator unless you solve that first equation for y. And that's your notes on inverse functions.